Module 5 of the Sanitation Safety Planning methodology. My name is Leonela Barreto-Dillon and I will be your guide in this module called Monitor Control Measures and Verify Performance. In Module 5, we will define and implement operational monitoring, verify system performance, and audit the system. In this module, we will produce one of the key products of SSP, which is an operational monitoring plan for regular monitoring and periodic verification. You remember that a hazard and a hazardous event create health effects. The risk is derived from the likelihood of hazardous events happening and the severity of the health effects. In order to reduce the risk, we have a control measure. Operation monitoring refers to monitoring if the control measure is working. Verification monitoring refers to the overall impact related to changes in the quality of the product, health, society, and environment. Ministries of health normally have a team dedicated to environmental health, covering topics such as drinking water, safety, sanitation, air pollution, occupational health, and chemical safety. They are also responsible for the oversight, monitoring, and enforcement of sanitation safety standards in private, public, and business premises in the environment and in the provision of sanitation service. Monitoring is a key environmental health function to track progress and inform management decisions. This is especially important given that safe sanitation systems depend on continuously provided services meeting the principles of safe management at each step. Remember that in Modules 3 and 4, we identified a number of existing and new control measures. Okay, so the purpose of Module 5.1 is to select monitoring points and parameters to give a simple and rapid feedback on whether those control measures are working as planned. This will show if the control measure is being effective, and if not, then we can make corrections quickly. Operational monitoring is the routine monitoring of parameters that can be measured rapidly to inform management decisions to prevent hazardous events. Operational monitoring collects and uses simple observations and measures such as flow rate to check on detention times, temperatures of composting, observations on on-farm practices, etc. And sampling and testing such as chemical oxygen demand, biochemical oxygen demand, and suspended solids. Practical considerations dictate that only a limited number of indicators can be monitored. However, we need to ensure that we do monitor the entire sanitation service chain. At the toilet step, possible monitoring parameters are the quality of the construction of the superstructure, existence of hand washing facilities, cleanliness of the facilities. Data on sanitation and hand washing facilities should be collected through the inspection of dwellings and buildings, which might be done routinely in periodic special surveys or in the national census. At the containment, storage, and treatment step, possible parameters are the state of the cover, whether it's cracked or damaged, visible reported overflows, idle time of dry sanitation technologies. As in the case of the toilet step, data in this step is collected through the inspection of dwellings and buildings. The WHO developed new sanitary inspection forms for sanitation systems. These are short, standardized observation checklists that can be adapted and used by stakeholders to assess risk factors at or near the sanitation facilities and identify appropriate actions to safeguard public health. Sanitary inspections might be used by community representatives, government officers such as environmental health inspectors or field officers from national and international organizations. Sanitation inspections are complemented by a set of management advice sheets which provide guidance on operation and maintenance of sanitation systems and possible remedial actions for the risk identified. At the conveyance step, possible monitoring parameters are the use of personal protective equipment by sanitation workers, the number of licensed operators, the use of the predefined roads, extent of leakage in sewers, and cleanliness of the sewers. Data on the emptying and transport component of on-site facilities and on leakage or overflow of untreated sewage should be collected from customers, formal and informal operators, and when relevant, licensing authorities and regulatory bodies. At the treatment step, typical monitoring parameters are flow rate, retention times, chemical oxygen demand, biochemical oxygen demand, and suspended solids. Composting temperatures. Data on the effectiveness of the sludge and sewage treatment should be collected from operators and verified by occasional sampling and independent laboratory analysis. At the end-use disposal step, monitoring parameters include visual inspection of the application irrigation process, actual versus planned duration of the withholding periods, frequency with which farmers are wearing personal protective equipment, and we have to carry out inspections of nearby farms with routinely or periodic surveys. Keep in mind that monitoring of all control measures might not be practical. The most critical monitoring points based on the control of the highest risks should be selected. Critical limits are usually numerical limits based on a parameter measurement. In some cases, qualitative limits are appropriate. This is a typical recording format. The following aspects should be identified for each of the monitoring points. What is monitored? What is the limit? What's the method of monitoring means how it is done. Where is it monitored? Who will monitor? What is the frequency of monitoring? An action to be undertaken when the critical limit is exceeded. Now, let's talk about verification of performance. Verification monitoring is performed to periodically verify whether the system meets the intended performance outcome, such as the use of sanitation facilities, the reduction of fecal load in the environment, the quality of the effluents or products, etc. Verification monitoring can be done by the SSP team or an external authority as part of the surveillance function. Typical verification data are, for toilets, the use of toilet facilities. Containment, storage, and treatment will be pathogen concentration in groundwater. For conveyance, the amount of fecal sludge transported to the treatment site. For treatment, microbial testing of effluents, for instance, E. coli or Helminth X. And for end use and disposal, also microbial testing of crops, fish products, and waters at exposure points. Model 5.3, Audit the System, provides additional independent evidence of the system performance and quality of the SSP. A system audit might not be feasible in the initial stages of SSP, especially in the absence of regulatory requirements for risk assessment management approaches. However, audits ensure that SSP continues to contribute to positive health outcomes by checking the quality and the effectiveness of SSP implementation. Auditing can be done by internal, regulatory, or independent auditors. it should demonstrate that the sanitation safety plan has been properly designed, is being implemented correctly, and is effective. Great! So we have now completed Module 5 of the SSP methodology. You have learned how to define and implement operational monitoring, verify system performance, and audit the system. I recommend downloading the 2018 WHO guidelines and learn more about the monitoring functions of environmental health authorities. Also, you should carefully read Module 5 of your SSP manual. In the following lecture, we will continue with the Sanitation Safety Planning methodology. In specific, its final module, Module 6, called Develop Supporting Programs and Review Plans. Thanks for watching and happy SSP.